In part 1, we saw how to read text files. Now, let's look at how to write a file. Writing files is actually much easier than reading them, but there are a few additional system routines we need to learn. To write a file, we create a new object. It's an object of type printWriter. The P and the W are both capitalized. This is the object that represents our output file. So here, I've created a variable of type printWriter, and I'm calling it output file with a capital O because I'm thinking of this as a global. Because it's an object, we have to construct it. It would be nice if it had a normal constructor, so we could just create a new printWriter. But it doesn't work that way. Printwriters have their own custom constructor called createWriter. It's a lowercase c and a capital W, all one word. createWriter takes one argument, a string that names the file you want to save. And if you just name a file like this, it will show up in the same directory as your sketch. Just as we only read plain text files, so too, using this technique, do we write plain text files. Because we're writing plain text files, we'll always want to give them the extension .txt. So these two lines together declare a printWriter object and then actually create one. And of course, you could smush these together on one line if you wanted. Now that you have the output file, it's really easy to write to it. We just send it the message printLine. And the arguments to printLine are any arguments that we would ever hand to printLine. Strings, variables, combinations of strings and variables, anything that we would have put into printLine to print to the output window, we can put into this version of printLine. It's the same printLine, only we send it as a message to output file. So we precede it with output file dot. You can also use print instead of printLine if you don't want the carriage return at the end. There's one more thing you need to know, and that's how to tell the computer you are done writing the file. And you do it by sending these two messages to output file, flush and then close. They don't take any arguments. Once you've done this, you are done with the file. An output file no longer points to it. Output file is just not useful to you anymore because you have closed the file. If you want to open a new file, that's fine. Go ahead and call createWriter with a new file name and you'll have yourself a new file. But once you flush and close it, it's over. You may be wondering what this flush and close business is about. The answer is a little computery, but I think it will be useful for you to have a mental model for what's happening here. So let's look at it in very general terms. Suppose we have a program where we've just created the output file we discussed, and now we want to print 5 lines. Each line has just the letter A, B, C, D, and E because I want to keep things simple. Before we watch what happens here, let's look under the hood. The computer maintains an area where it saves up the information that you want to write to the file. This is called the queue. And every now and then, all the information in the queue gets written into the file, represented here by this blue box that looks like a torn piece of paper. So now let's execute the program. We start with the first line. We want to print the line that contains nothing but the string A. So that goes into the first position in the queue, the first thing that will get written when it gets copied off into the file. So an A goes into the first box and we're done. Now we look at the second line and we want to print the string B. So that goes into the next position of the queue and we're done with that line. Now we're at line 3. We want to print the line containing C. So we put a C in there and we're done. We move on to the next line. But before we execute it, the computer says, you know what? I think it's time to copy this queue off to the file. That is a process that for historical reasons is called a flush. So when the computer decides, hey, hold on, wait, it's time for me to flush the queue, it then says, okay, the program stops running for a moment and I'm going to copy the contents of the queue into the file. Why do we do this crazy thing? Because writing to the file can actually take a little bit of time. So rather than write to the file every single time you write a line, it batches them up so that only when there's a bunch of stuff to get written, it all gets copied off at once. And that is a lot faster than writing each line one at a time. And the computer tries to be very thoughtful and very clever about when it decides to flush. And normally it does a very good job. So okay, we're done with the flush. Now it comes back to our program and says, oh, you want to send the line D to the output file. So I'll put that into the queue just like always. Now it's at the head of the queue. I go to the next line. You want to print an E. That goes into the next position in the queue. And now let's suppose that that's the end of our program. We have a curly brace and the program quits. Here's what might happen. You end up with a file that contains A, B, and C. And that's it. What happened to D and E? They got lost. They were sitting in the queue, and when your program quit, the computer just said, oh, okay, shut everything down, and your queue, your waiting buffer of stuff to be written to the file, never got written. It got abandoned. This is not good. This is really not the way things should be. So let's roll backward in time. We've just written E into the buffer, and now to make sure that everything gets closed up properly, we call flush ourselves. We say to output file, listen, I want you to flush now. And so it says, all right, I'll flush. I'll copy the contents of the queue into the buffer, and I'm done with the flush. That's almost enough, but we still have to do one more step. We have to tell the operating system that we are done with the file, because the operating system needs to kind of wrap it up in a nice way. So we send the output file the additional message, close. By calling close, everything gets properly ended and our output file is complete. So let's put this in action. I'm going to write a little sketch that lets me move the mouse around on the screen, and every time I hit the space bar, it writes the current mouse X and Y into a file. First, I'll create an object of type printWriter. I'll call it output file. And in setup, I'll create my graphics window, smooth things out, and I will create my output file by calling createWriter with the argument mousepoints.txt. That's the name of the file I'm going to write. Draw doesn't do anything interesting, clears the background, and draws a circle around my mouse. All the interesting stuff happens inside of keytyped. If I hit the spacebar, then I send the message printLine to output file. And what I print is the X value, followed by a comma, followed by the Y value. If I hit the Q key, meaning I want to quit, then I send output file the messages flush and close. Now the file is closed down, and because I'm quitting, I call exit, which causes the program to exit. Let's run this. Here's the program. It's exactly what we just saw. I'll run it. I'm moving the circle around with my mouse. I'll hit the space bar. I'll hit it again and again. One more time. I've hit it 5 times now. Now I'll hit the Q for quit. If I look in the directory for this sketch, I see 2 files. The PDE file for the program we just ran, and the text file we just made. If I open up the text file, we can see it's a plain text file that contains 5 lines. And each line has exactly the information we expect. The mouse X, comma, and the mouse Y. Each time I hit the space, we wrote a new line. When I was finished, I called flush and then close. So to recap, here's everything you need to know about reading and writing text files. To read a file, we hand the name of the file as a string to load strings. That gives us back an array of strings. The first entry in the array is the first line in the file. The second line in the array is the second line in the file, and so on for all the lines in the file. To write to a file, we declare a new object of type printWriter, and we create it by calling createWriter with the name of the file. Then we print as usual with print and printLine, but we now treat those as messages that we send to the file we just made. So we precede the calls to print and printLine with the name of the printWriter object and a dot. When we're all done, and this is important, we call flush and then close to properly wrap up the file. Now that you can read and write files, you have access to huge amounts of data that you don't have to actually embed in your program itself.